Okay, so you tested last Friday. Some of you still need to take your quick retake, but we'll talk about that after the lesson. You did really well. You were grateful for a quick retake, though?
Indeed.
Yeah, I thought so. Chapter 4 was one of the hardest chapters we'll do all year. So take a big, deep sigh of relief, because Chapter 5 is going to feel pretty friendly in comparison to what we just did. That chapter just kept building and building and building and building and building, and then they wanted you to do everything all at once, right? Those last couple of questions that we worked on. Today we're going to be doing operations with functions and also composition of. This page is something that you know. It's just presented in a new fashion. So we will be using f of x and g of x up here to answer all of these problems, okay? This is read f plus g of x. And all that means is f of x plus g of x. That we're used to seeing, right? Now that I know f plus g of x means f of x plus g of x, I can look at my functions up here. Here is f of x. Here is g of x. Go ahead and combine any like terms. Is that what you guys got? Good. All right, so if this had just said f of 3, where would you substitute 3 into? Into f in for x, right? But this wants f of g of 3. F plus g, sorry, thank you. F plus g of 3. So I just figured out f plus g. What are we going to do now? Not times it by 3, but we're going to substitute it back in. So f plus g at 3 would be, I'll set it up over here so I have more room, 3 squared plus 2 times 3 minus 3. What do you get? 9, 15 minus 3 is 12. So far, so great? All right. Minus is one of the harder ones just because you make a simple mistake, and I'll point out what that is right now. So f minus g of x. Let's go ahead and let's set that up. So f of x minus g of x. And I just made the mistake. Chance thinks he knows. Anybody else?
Wouldn't that minus change the plus 1 to minus 1?
Yeah, okay, so there's 2 people that noticed what I did wrong. So I've got to take away the whole thing, don't I? It's f of x minus the whole function g of x. And what happens there? It changes both signs. So don't make the fatal error on those of forgetting to distribute your sign. Now that you have f minus g of x simplified there, find what f minus g of negative 2 is. Substitute in negative 2. Oh, I should have put what this is. F of x minus g of x. What'd you guys get on that one? Good. All right. Product, this is red, f times g of x, and all that means is f of x times g of x. All right, let's set that up. F of x times g of x. You got a nice fancy FOIL problem now? Go ahead and multiply that out. You guys don't need me. But check my work, make sure I don't make any mistakes. I'm good? All right. Now let's figure out what f times g of 2 is. We've got f times g, substitute in 2. I've got enough room over here, so I'm going to do it here. Pay attention to your order of operations on this one. That gets some of you in trouble sometimes. So that means exponents first, right? Let's see. 16 plus 4 and 16. Is it 0?
Yeah.
All right, you guys are fast. All right. Quotient. This one takes it just a little step further than what we've been doing. What number can we not divide by?
0.
0. So when we set up a quotient of things that don't reduce to a whole number, we end up with a fraction, right? And if I have a variable in the denominator, that means it has a chance of equaling 0. So we can set up the division problem, but then we also need to talk about what limits its domain. So f divided by g of x is just f of x divided by g of x. Go ahead and set that up over here with our equations, our functions that we have up at the top. F of x over g of x. And you guys just told me that a denominator can't equal what? 0. So we'll come over here and we're going to say 2x plus 1 cannot equal 0. And that marker is running out. All right, let's solve that. 2x cannot equal negative 1. X cannot equal what? Negative 1/2. Now in your homework today, it's going to say, what is the domain in interval notation? And we have kind of forgotten about interval notation because we haven't used it for a while. So let's refresh. We've got brackets and we have parentheses. What do the brackets mean? Anyone? What's that?
It can equal.
It can equal that, and this one is, it can't equal that, right? So we're coming over here and we say x can't equal negative 1/2. So what are we going to be using? We're going to be using parentheses. So can it equal any other number? Any other number, right? So on our number line, that would be, we can go from negative infinity to what? Negative 1/2. And it can't equal negative 1/2. So we're going to jump right over it with that parenthesis. But then it could also go from negative 1/2 to where? You haven't done that for a minute. But did that refresh your memory? So that means all of the numbers but negative 1/2. All right, so operation on functions is pretty friendly because it's familiar. This is friendly, but new. Composition of functions. The only one that can equal 0. Yep, the numerator can be any number, right? Including 0. Because 0 divided by any other number is 0. By any other number, right? Composition of functions means we're combining functions in a way other than we just did add, subtract, multiply, and divide, right? We read this, in fact, I'm going to say this is g of f of x. You're going to be lazy and you'll probably call it Goff, but we read it g of f of x. Now you don't need to write this down, but I want to give us a little back work. If I told you to do g of 3, what would you do? Here are our functions. What would you do? So we take 3 and we'd substitute it in, right? All right. Another way to write g of f of x, and I'm going to make this big and obnoxious, is g right. A second ago I wrote a 3 right here. You guys had no problem. You said I'm going to take 3 and I'll plug it in for x. What do I have there this time? I have f of x. So written in this notation, g of f of x, is it obvious what we're going to substitute in for g? Kind of. We're going to substitute in the whole function f into g. So I'm going to take g, and wherever I see that x, I'm just going to put a set of parentheses. And what are we going to substitute into those parentheses? F of x, which is 2x squared plus 3. Now simplify that. 2x squared plus 3 minus 6 is 2. So we always work backwards. This says take f and substitute it into g. How about on number 9 here? This says take f and substitute it into what? J. So I'm going to look over at j. Here is j. There's my variable, so I'm just going to put a set of parentheses there. Minus 4. What goes inside that set of parentheses? F of x, which is 2x squared plus 3. Go ahead and simplify that. Questions? Okay. Oh man, look what's happening here. How many do I have in this case? We've got 3.
You're missing a parenthesis on the end.
It is?
Yeah, so it's the last one.
It was? How rude.
No, not the last question. Number 12.
Oh, this one. 1, 2, 3, 4. 1, 2, 3, 4. Thanks. All right. So we're going to start from the end, and we'll work our way to the left. Okay? So this says take h of x and put it where? Into f. All right. So this is going to be a 2-step problem. H into f. So here comes f. There is where the variable is. So I'll just put a set of parentheses there. Zoom out so I can see my functions up there. All right. What goes inside that set of parentheses? H, which is the square root of 2 minus x. All right, go ahead and clean that up. You'll be happier if it's a nice thing before we plug it into the next one. Squaring a square root, what happens? Poof. So 2 minus x plus 3 would be 4. 7 minus 2x, negative 2x plus 7. Okay, so this was this first part, f of h of x. And this is what we got. This is f of h of x. But now where do we need to substitute it?
G.
Into g. All right, so let's take our g. Here we are, variable minus 6. What goes in that spot? The f of h of x that we just canceled, or calculated, not canceled. So that would be 7 minus 6 is 1, so negative 2x plus 1. Questions on that one? All right, I would like you to do g of g with your neighbor. What does that mean? Put g back into itself. Let's see how you do. Compare with your neighbors. What did I do? Here? What did I do?
So it's 7 minus 2x, 7 minus 6 is now 7.
That better? Thank you. I messed up a sign there, you guys. All right, g of g. You know where to start? Who's already done? You guys are fast. All right, so here's g. And we're going to put g back in there, and g is x minus 6. So x minus 6 is x minus 12. How'd you do? Good. I like the thumbs up. That makes me happy. Okay, we're only going to do one of these, and you're going to see a couple of them in your homework. So watch this closely. These problems are your best friends. I've got to zoom out so I can see all those functions there. So just like we started at the right and moved left, that's what we're going to do here. You do not want to figure h of g. You don't want to do g of f. It's not a g. J of f of g of h. You don't want to do that and then plug in number 1. That sounds horrible. So this is the shortcut. Plug 1 into h. Tell me what you get.
1.
2 minus 1 is 1. Square root of 1 is 1. All right, so on that part I just got 1. Now I want you to plug 1 into...
No, because you're not taking the square root of it. It already is square root.
Are we good? Because I made a mistake before, but now we're good. Okay, so for h at 1 we got 1. So now take that 1 and plug it into... You're seeing the pattern already. G. All right. 1 minus 6 is... All right, so now for this part, we got negative 5. Where are we going to put it? Into f. Negative 5. Into f. All right, 2 times negative 5 squared plus 3 is 25 times 2 is 50 plus 3 is 53. And now where are we going to put that number?
J.
Into j. 1 over 53 minus 4 is 1 over 49. All right, your assignment should be ready to go. I think it opened just a couple of minutes ago. Let me know if otherwise. Were there any people who wanted to do the quicker take on their test right now? Okay, I'll get it open for you.